Now we've looked at the A-B-O system, and I'm just going to recap that very briefly now. So here we have blood group A, and the blood group is determined by the red cell, so this has A antigens. But if someone is blood group A, they're going to have B antibodies or anti-Bs in their plasma. If someone's blood group B, it's the red cells that are B, but there's going to be anti-A antibodies in the plasma. If someone's blood group AB, they're blood group AB because it's the red cells that have the A and the B antigens. So this is the way we've drawn an A antigen, this is the way we've drawn a B antigen, and as you can see there are no antibodies in the blood if someone is AB. But if someone's blood group O, that is blood group 0, then there are no antigens on the red cells, but there will be anti-A antibodies and anti-B antibodies in the plasma. And these antibodies are described as being naturally occurring. So you're going to have these type of IgM antibodies in the plasma to any of the ABO groupings that you don't have. So blood group A is going to have the antibody B in it because there's no B antigens. And it's the same with blood group B. There's going to be anti-A antibodies because there's no A antigen. So for some reason you develop antibodies to any of the ABO antigens you don't have. And these are naturally occurring. Whoever you look in with a blood group A, they are going to have anti-B antibodies in their plasma. And these develop during the first few months to the first year of life. So when a neonate is born, they don't have these antibodies, but they develop them in the first months and first year of life. And the reason they develop them is probably because they're exposed to bacterial infections and different sorts of food that stimulate the development of the antibodies. But we describe them as naturally occurring. Now, the next blood group I want to introduce you to is the Rhesus factor. Now, the Rhesus factor is so called because it was discovered using Rhesus monkeys. And the Rhesus factor is actually a complicated factor with many subgroupings like C, D, and E subgroupings. But the one that is active, that is immunologically active, that can act as an antigen is the D factor. So when we're talking about the Rhesus factor, really what we're talking about is the D factor, the letter D factor. Now what the Rhesus factor is, it is an additional blood group, and it's simply present or absent. So if someone's blood group A, as we see here, we notice that there are A antigens on the surface of the red cell, but we notice at the moment there are no other antigens on the surface of the red cell. But if someone is A Rhesus positive, then they will have Rhesus factor antigens on the surface of their cells as well. And this is another antigen. It's protein based and it's present or absent, and like the ABO system, it is genetically determined. So what we've done now is we've added Rhesus factor antigens to someone who is blood group A, and we've turned them from Rhesus negative into Rhesus positive. And in the same way, if we look at blood group B here, so we're looking at the outside of the B erythrocyte, the outside of the red cell, and we notice that there are B antigens. But we also notice that there are no Rhesus antigens on the surface of the red cell. So at the moment, this diagram is illustrating someone who is B Rhesus negative. They don't have the Rhesus factor. But if we add the rhesus factor as an additional antigen, we're making that an oblong antigen today, they are actually specific molecular shapes. What we've done now is we've converted this into a B rhesus positive. Looking at the AB, we see there are A antigens on the surface and B antigens on the surface. But we notice there are no rhesus factor antigens at the moment. This person at the moment is rhesus negative. They are AB negative. But if we add them, they will become rhesus positive. So we've now diagrammatically turned these people into rhesus positive as well. And finally, with the blood group O, we notice there are no antigens on the surface of the erythrocyte. So at the moment, there are no rhesus factor antigens. So this is diagrammatically illustrating someone who is rhesus negative. But if you want to diagrammatically represent someone as rhesus positive, now we see that there are the rhesus factor antigens on the surface of the cell. So this person is now O rhesus positive. So the rhesus factor is mostly the D factor, and it's simply present or absent. So that means in addition to being A, B, or O, someone can be either of those groups with or without the rhesus factor. So blood groups can be A positive or A negative, B positive or B negative, AB positive or AB negative, and O positive or O negative. So that describes the blood groups simply using the ABO rhesus system. Now, blood groups are quite a bit more complicated than this, and in fact, the last time I read anything about it, there was 35 different types of blood groups which have been identified. But the ABO-D or the ABO rhesus are the immunologically most significant ones to be taken into account first for blood transfusion. But most transfusion laboratories will take into account more factors than the ABO rhesus factor. Now, we have noted that in the ABO system there are naturally occurring antibodies in the plasma. Now, with the rhesus factor, there are no naturally occurring antibodies. So if someone is rhesus negative, there will be no rhesus factor antibodies, no rhesus factor immunoglobulins in the plasma. And whether someone's rhesus positive or rhesus negative makes no difference, there still will be no rhesus factor antibodies in the plasma. They are not naturally occurring. But if someone is exposed to rhesus positive blood who is rhesus negative, then that means they will be exposed to rhesus factor antigens. And of course, an antigen is something that causes the body to produce an antibody, an immunoglobulin. So if someone's rhesus negative and they are exposed to rhesus positive blood, even on one occasion only, because this D rhesus factor is very antigenic and immunologically stimulating, then after that person has been exposed to rhesus positive blood, from then on they will have rhesus factor antibodies in their plasma. And that means if they're exposed to rhesus positive blood on a future occasion, there can be an immunological reaction. And we'll consider these in more detail when we consider the condition of hemolytic disease of the newborn.